Work it, make it, do it, make sense.
Hi guys, thank you for coming. My name is Mario Fusco. I'm from Italy and I work for rethought on the JBoss rule engines, on rule. But I'm here to speak about a bit of functional programming and in particular under a specific point of view. So how many of you are familiar with this book? Yeah, lots of you. I started programming professionally kind of 20 years ago or probably a bit more. And at time, this book was my Bible. I mean, really, you weren't a cool programmer if you didn't know all these patterns in this book. And the more pattern you use, the more cool you were. So, yeah. And then, you know, people started doing crazy thing, overcomplicated thing for no reason, basically. Why this? Because the main problem of this book is that it was a great book, actually, but it was totally biased toward a single paradigm, that is the object-oriented one, okay? And instead, there are a few things that could be better and more concise with functional programming. And in particular, this book is divided in categories, and probably the most relevant category is the one that is called behavioral patterns. I hope that if I give this book to a smart student nowadays, the first question he will do will be something like, hey, but this book is about object-oriented. Why there is a behavioral section here, a section about behavioral pattern? A behavior is not an object. A behavior is an action, is a function. Okay, so why you are overcomplicating it, modeling action with object? That is exactly what they did in the book. Okay, the good thing about this book is that it gives us a common background, a common vocabulary. So if I say to my colleague, here, look, here I used a strategy pattern, I don't need to say much more. It's clear, okay? So this is the good thing of this book. But again, we are doing things in a way that is more complex than how it should be, okay? So let me show this with a first example. So what I did here is that I implemented some of these patterns, mainly, as I said, the behavioral ones, in the traditional Gang of Four way, and then I'm trying to do some live coding to translate this implementation in a more functional way. If you want to review the code, you can clone this repo, this GitHub repo. Okay, so let me start with a first very simple example. I have the command pattern here. So how does it work? I have this command interface, and I have a different implementation of this command interface, okay? And then I want to execute this list of commands, so I pass this list of commands to this executor, and I then can execute all of these different tasks, okay? I know this example is very trivial, but I think that it really shows the point that I was mentioning before. We have an action here that is the function, that is the only relevant thing of all this stuff, okay? But since the Gang of Four is totally object-oriented, about object-oriented programming, they couldn't model an action, they couldn't model a function in that point of view. So what they did is taking an action and wrap it with a command, taking a verb and wrapping it with an unknown, okay? But if you think about it, the only relevant part is this, right? So what I want to do is take this and make it a function. And to have a function in Java 8 or Java 9, the easiest thing to do is having a static method, okay? To have a pure function, because a pure function only depends on the input, cannot access the state of the object when it is declared. So you make it static, and you are done, okay? So this is, for instance, the command or the action to log something, and then I can have a different command to save this message somewhere, okay? And then I can send this message somewhere else, okay? So what I do next? Here I had to use this command interface. But if you look at it, in reality, the single method inside this command interface has exactly the same signature of another interface that we already know, that is the Runnable one. So I don't need to declare another interface. What I have to do is that I can take this method and let it run on a list of Runnable instead of a list of command. Right? And then I could do something like this. And run all the Runnable, okay? At this point, I'm ready to redo this stuff again with my functions. So I don't need this, okay? I make this static. This is a list of Runnable. Okay, and then I have my Runnable that are represented as lambda expression. That's all, okay? So if I try to run this, it will print those three things in the same way, but as I said, in a more compact way. Here you have a quite big signal-to-noise ratio, okay? I just took only the signal and left the noise out. And the signal for me, again, is the action, is the function. Okay, so again, I know this is a super trivial example, but probably it shows the point. Let's see something quite similar, that is the strategy pattern. So again, this is the canonical implementation with Gang of 4. I have a strategy, I have a text formatter, okay, that is my strategy, that is made of two things. I can filter a text to decide if I want to print it or not, and then before printing it, I can do some transformation to format it, okay? So I have a few implementation of this. I have one that is just accept any text and print it as it is, and then I have another one that only prints errors in uppercase and so on, okay? And then I have this text editor that is passed with a specific formatter, with a specific strategy, and I use the strategy to publish a given text, okay? But once again, here the only signal, the only relevant part is this method. So what I can do here is to, okay, make this thing static again, and then I need two more things. I need two functions, two lambdas that implements my strategy, okay? So the first one is a predicate that tells me how to filter the text. So I can do this. Okay. And the second one is a function from string to string that allows me to format my text before printing it. Okay, that's all. And then what I can do to print this stuff is calling that method. Okay, and then I had to pass to this new method the two lambdas. So I was using this formatter for instance. So I can pass a first lambda like this. Okay, and then the second one is the one that render all the text in uppercase. Okay, and I have exactly the same effect. Okay, so once again, very simple, but just to show the point, just to show that all this strategy, command, all this fancy object, as they have no reason to exist. That's all. That's the truth. Okay. Next one. This one is the template that is also pretty useful, I think. So what I did here? Here I have a resource. This resource is created. Then it can be used in different ways. Okay. But the resource has to be disposed. Otherwise, I will have memory leak or file pointer leak or SQL connection leak, whatever. I have to dispose this resource, okay? And I simulated the fact that these two methods, the two business methods, can fail with this random failure, okay? Once out of 3 times, it failed. So if I run this as it is, of course, yes, it may or may not fail, but the biggest problem is not that this is failing, that's okay. The problem is that since it is failing, I'm not calling this dispose method, and I'm causing a leak into my system. And I want to avoid this, okay? How I can achieve this with the traditional Gang of 4? I give to my user a template of how it should use my resource, okay? So this is the template. The template is open a resource, do something with the resource, and then in a finally block, you close the resource, okay? And then this method is abstract. So the actual implementers of my template should provide an implementation of my templating by saying what you should actually do when you want to use the resource, okay? But how can you do this in Java 8? You can do, for instance, like this. Let me create this resource, okay? And then here I dispose the resource in the final block, so it is safe. I won't have any leak. Okay. And then what I do here? Here I want to consume my resource. I want to do something with my resource. So what I have to pass here is just indeed a consumer of my resource. Okay. And what I do is just this. Okay? So after this, to achieve exactly the same behavior of this template, I can call this execute method, and then I will pass it to it a consumer of my resource. So I can do something with my resource. I can use it, I can employ it, okay. And then I can run this thing. Okay, this is the happy part, but okay. If I'm unlucky, I will get the error, but the relevant thing is that anyway the resource has been disposed. Okay, and I'm not creating this fancy template. I'm just passing a consumer to the method that knows how to properly create and dispose that resource. Okay, so this is also called the land pattern, because if you look at this in this way, this method is creating a resource for me, lending the resource to me so I can use it, and then I return back the resource to the API that is in control and knows how to do with it, or what to do with it, and then it will dispose it. Okay. Next example. Okay, let me skip the observer for time reason because it is very similar to the former one. It is another consumer. This time you are just consuming the event that you are observing. Same thing, okay? So let's see something more interesting. Okay, so taxes. This is my domain now. I have a library of taxes. And then I have a situation. I want to implement a salary calculator where I may or may not apply all these taxes or a subset of them. Okay. So how I do this with the Gang of 4? I do this using the decorator pattern. Okay. Why I'm using the decorator pattern? Because, as I said, I want to, let's say, dynamically create the set of taxes that I want to use. Okay. So I have a default salary calculator that just divides my gross annual by 12, and then I have these decorators. Okay. So a decorators just does the calculation and then pass the result to the next decorator. So you have different implementation, the one that applies the general tax, the regional one, and so on, okay? And how you use this stuff, you have to create, you have to coordinate this decorator, okay? So you have the main salary calculator, and then you decorate it with the decorator that applies the general tax with the one that applies the regional tax, and so forth. Okay, so you can try to calculate your net monthly salary, and this is the result in this case. And what's the advantage of this, as I said, is that if for some salary I decide that I don't want to use the regional tax, for instance, I can just comment it out, and I'm not applying the regional tax anymore. Okay? So this is the advantage of doing this. But of course there is an easier way to do. If you think about it, what I'm doing here? I'm doing a concatenation of function, right? So how to do the same in functional programming? This is very easy. I can take this one and actually this is a double unary operator, okay, which has exactly the same signature of this method. You see, it just transforms a double into another double. So if I use also the same name, the compiler will be happy. Okay, and then what I do? I start from this. And then I do function composition, and then I apply the general tax, okay? And then apply the regional one, and then I apply the health insurance, and then I pass to it my salary. Okay, and I'm done. It's just this. I don't have all this fancy decorator thing, okay? And if you look at it, the other problem is that this is hard to read because you have to read it from the inside out, okay? While you read this in the right order. So if I print this stuff, sorry. If I print this stuff, I obtain exactly the same result as before. And of course, I also have the same effect as before. If I don't want to use the regional tags anymore, I just leave it out and I'm done. Same thing, right? But much more easy. So we could maybe want to do a different similar exercise. Maybe we want to provide to our user a way a function that takes in input the gross salary. Call it calc, return not double. That take in input the gross, and then it takes a varargos function and applies this varargos function to my gross salary in order to calculate the net. Okay? So if I want to do this, what could I do? I can put all these functions inside the stream, and then I can combine all of them to obtain a single stream. Okay? So I can do a reduce. For the reduce, I need two things to define a reduce operation. I need the zero and the operation that I want to use to reduce the different item of my stream. Okay? So now I'm doing a function composition. So what is the zero for function composition? The identity function, of course. Okay, I have to use this identity function, okay. And then the operation that I want to use to combine them is, of course, that the and then one, okay. Now I have a function, okay, and then I can apply this function to the gross, okay, and I'm done. So how can I use it? I can do, for instance, calc. I want to use this, and then this, okay, and maybe this. For instance. Okay? And I'm done. Nope. Okay. Make sense? Okay, next example. Okay, this is another interesting one, the chain of responsibility. Okay, so what's my domain now? I have a file that I want to parse, and I have different components. And each component has its own responsibility. So one component is responsible to parse a text file. I have another component that is responsible to parse a presentation or an audio format or a video one. Okay? So what I do, and this is the reason why it is called the chain of responsibility, I have 4 components in this case. Each one has its own responsibility, and I create a chain of them. I pass the the file to be parsed to the first element of the chain, and then the file is passed to the other element until it finds the one that is able to parse that file. Okay. So how do you implement this with the gang of 4? So as I said, you have you have a file parser. I defined an abstract file parser just to create this chain, so each parser has a pointer to its next one in the chain. And then I have a text file parser that is able only to parse the file of type text, and same thing for the presentation one, for the audio one, and the video one. Okay. Then how I use this stuff? I create my for parser, and then I create the chain. So I say that the presentation parser is the next to the text one, and so on. Okay. So if I pass to it an audio file, what will happen is that the audio file will reach the text parser. It won't be able to parse it. So it will call the next one in the chain, that will be the presentation one. Same thing, it will reach the next one in the chain, that will be the audio one. At this point, it will be able to parse it, and it will just do its job without invoking the video file parser at all. Okay, so this is how the chain of responsibility patterns work. Let's do something similar in a more functional style. So this is my function parsing, for instance, a text file. Okay, and I make this static. Okay, so I don't want to create this chain now. I don't need it. So what I do, so I won't have this next anymore. And what I do, if this is not a text file, okay, I really don't want to throw an exception. If you throw an exception, every time you throw an exception in functional programming, a kitten die. So don't do this, okay? So what's the next option? The next option is, of course, returning null. And if you do this in functional programming, the whole family of kitten die. Don't do this, okay? So what you do is modeling with the type system what this function actually does. This function may or may not return a result. This function optionally return a result, okay? So instead of return a string, I will return an optional of a string. Right? So I return this. Optional of this. Okay. And of course, in this case, I will return an empty optional, right? So I can do exactly the same with the other formats. So I have the presentation one. Then I have the audio one. Okay. And then I have the video one. Okay. So what I do now? Now I have my 4 parser that are just function now. How I use them? I don't have this chain anymore, but I can put this 4 function inside the stream once again. So I will create a stream of them, put in this in my stream, so it will be So the text was first, then I have the presentation one, and then I had the audio one, and the video one. Okay. Now there is a small problem because the Java type inference is not smart enough to understand what I'm putting inside this stream, so I should give it an hint. So what I'm putting here, this is a stream of function from file to an optional of string. Correct? So what I do now, I pass my file to all the function in the stream. So I can do this. I have a function and I do f dot apply, passing the file. Okay. At this point, I have a stream of optional. I have a stream of optional. I want to take only the optional that has a value, because it's the one that actually was able to parse the file. So I'll filter only the optional that are present, and then I take the first one, okay? And what I have at this point. So after this map, I have a stream of optional. Then I filter away only the one that are present, so I have a stream of optional. And then the find first also return an optional, okay? Because the stream may be empty. And in that case, he doesn't know what to return. So this means that at this point, I have an optional of a string, okay? And I have to unwrap this double level optional, because I don't know what to do about it. There is an easy way to do this. I flat map, and I don't want to do any transformation. I just want to flatten these two level optional into a single one. So I just pass the identity function to it, and I'm done. Okay, and then I get my result. And I'm done. Okay, so let's see what happened. Okay, cool. So, question for you. Is the parse video function invoked in this case or not? Because here what it happened is that, as I said, the audio file reaches these stages. So the audio parser is able to parse this file, and it doesn't invoke the next one. It doesn't invoke the video parser. Okay. What is happening now? I'm invoking all the 4 functions, or I'm still not invoking the video one? Who thinks that I'm invoking the video one? Okay. Actually, I'm not, because the stream is lazy. Okay? So when I say find first, it invokes the parse text, it invokes the parse presentation, then invokes the parse audio, then finally I have an optional that is present, and since the stream is lazy, I don't need to invoke the parse video function at all, and I can quickly demonstrate this if you want. So probably I can do something like this, just to be sure or whether I'm invoking a function or not. Okay. So as you can see, I'm not invoking the video one, right? Okay. Another thing, here I know that this bit is a bit complex to get, but if you are in Java 9, there is an easier way to do this. You can use, in Java 9, there's a method to transform an optional into a stream. So if you just do, you don't need this flat map, and you don't need also this filter. You just do, you just do this. Okay, optional. Okay, and if you, again, this only works in Java 9. If you are in Java 9, you have this stream method. So, okay, in Java 9 there is jigsaw, but actually there is also something useful. So, and you will obtain the same result. Okay. Next example. The interpreter. Okay. Okay. So what I want to do here, I want to interpret this expression that is written in reverse Polish notation. Not because I'm particular fan of this notation, but just because it's easy to parse. It's easy to parse because I parse the token and I process the token by putting it on a stack. So I put 7 on a stack, then I put 3 on a stack, then the next thing is an operation. So I pull 7 and 3, I do 7 minus 3, that is 4. Then I put 2 and 1. 2 plus 1 is 3, and then 4 by 3 is 12. And then the result of this is 12. Okay? How I do this with the gang of 4? With this interpreter pattern. So I defined this expression that is a method that is called interpret, okay? And then I have the add expression, and the interpretation of the add expression, of course, is the sum of the left and the right. And then same thing for the subtract, same thing for the product. And then I have an expression of a number that is just the number itself when it is interpreted. And then I have something to decode the right expression. Okay, and finally, I have the method that calculates this, putting this expression on the stack and working as I mentioned it before. Okay, so it's really a lot of stuff going on here. Let's try to simplify this. First of all, I need to define this operation. Okay. What I can do to define this operation is putting them inside a map. Put the function implementing those operations inside a map, having as a key the symbol of the operation itself. So I can do this. I have as key the string, and these are in binary operator. This is my oops. Okay, I didn't import this. Okay. And then I populate this map. So when I have a plus symbol, I will do A plus B, right? And same thing for the other two operations that are parsed by my interpreter. By the way, I'm not. I don't have any. I don't have any error check here. Okay, if the expression is malformed, it just fail. But this is just for simplicity. Okay, and then I'm ready to reimplement this. I don't need anymore to have this expression. I just can put the values on my stack. And what I do here is that I check if this string is the symbol of an operation. Okay, and if so, and if so, I will push on the stack the result of that operation, right? Otherwise, I can just push on the stack the integer itself. Okay, so this is not longer useful. I don't need to call this interpret anymore. And then I can try to do exactly the same thing here. Okay, and I will get the same result, right? Okay, 10 minutes left. So last example is the visitor one. What I wanted to do here. Okay, I have here I have a set of geometric figures. So I have the square that has a side, I have the circle, I have the rectangle, okay? And then I want to implement two kind of operation on this figure. I want something that calculates the area and something that calculates the perimeter of this figure, okay? So what I do is that all this figure implement is element interface, so I can accept a visitor, so the figure can be visited. The visitor will have to implement a different method for each of the elements that I want to visit. And then I can have an area visitor that when it's passed with a square, it will return the area of the square. And then so same thing for circle and rectangle. And then I can have a different kind of visitor for a different kind of operation that in this case will be the perimeter of the square, the circle, and the rectangle. Okay? And then what I do here, I have a list of figures. I use this visitor to accept one by one my elements and calculate the area and the perimeter and accumulate them and print them at the end. So this will be the final result. Okay. Let's do something. Let's once again do the same in a more functional way. Okay, so in functional programming, it is more similar to this visitor pattern is the pattern matching. Okay, we don't have pattern matching in Java 8 or 9. Hopefully, we will have it in Java, I don't know, 13. But we can. But there are a few libraries. For instance, there is one library that is called. It was called Java Slang. Now they had to call the name of the library for legal reason. Now it's called behavioural, or I don't know the pronunciation anyway. Is behavioural. That has lots of these functional facilities like implementing a quite powerful DSL for a pattern matching. Here I did a very easy DSL with this class to define a function that accepts a given class and does pattern matching on that class, and when that class is found, it applies a given operation on that class. Okay, let's see how it works. I have these figures. Okay, so this is still my domain, but I don't need this fancy interface anymore. So I'm just throwing it away. Okay. Okay. And now I can use my simple DSL. So I want to create a function that transform an object into a double. That could be, again, the area in one case or the perimeter in another case of that element. So let's call this area. It will be this. Okay. And then I can define this function with my DSL. So I have a method on here, and I say on square when this function is invoked with a square, then I will return the area of the square. So since I'm saying that this is a square, now for how I wrote this class, the Java type system is able to infer that this S is actually a square. So it has the side. Okay. And then I can define the same for the other figure. You see, it's a fluent DSL. It's quite nice, I hope. So this is reduce. Yes. Okay, makes sense? Tango. Okay. So this is my function that will calculate the area for these three figures. Then I can have something very similar for the perimeter. So this is this. Okay. Then this and it will be okay. And how I use this stuff? I take my list of figure. Okay, and then I can put them into a stream as usual. I can map passing one of the two functions, for instance, the area. Let me make this static. Okay, and then and then I'm done. I can do a reduce. And then I can sum. Okay, so this will be the area, and of course I can do the same thing with the other function. Okay. So I should hopefully obtain the same result. Okay, so yeah, that's all. I think that I showed that you can re-implement, rethink to the gang of 4 pattern in a more functional way, and in this way the code is far more concise and it's far more I hope also readable. because yeah, probably you need a bit more time to understand all the tricks, but I believe it's just a matter of familiarity. I mean, you are really, or personally, I'm really familiar with the object-oriented style because, again, I did this in the last 20 years, so of course it's super obvious to me and for all of us, but probably we are not familiar in the same way with this functional approach. But when you use it for a bit, you will find that it will be, in many cases, easier and far more concise and readable than the traditional object-oriented approach. Okay, sorry, my time is up, so no time for question, but I'll be here so I can take question offline if you want, okay? Thank you.